Hi everyone, this webinar will be on the digestive system, which is part, again, of topic 1. So digestion can be defined in several different terms, but it is the process of breaking down food or breaking that food down into energy from whether it be animal products or whether it be from plants. And it's turning that food into energy and also obtaining all the nutrients that food has as well. So the main process of digestion includes breaking down food and drink into its basic chemical structures. That breakdown can either be chemical or mechanical, and it's about the absorption. So in the digestive system, there are two key parts. The first is ingestion, which is the actual process of taking food into the digestive system through the mouth, and digestion is the chemical and mechanical breakdown of that food.
And with her new teeth, she can take on more solid foods. Digestion starts in the mouth. Teeth grind up the food. Then, special glands under the tongue pump out saliva to help break down and lubricate the food on its 12-hour, 13-foot journey through the gut. It'll pass from the stomach into the coils of the small intestine before finally passing into the large intestine. Waves of contracting muscle keep the food moving, a process called peristalsis. These contractions are so powerful, we can even eat upside down. For the first time, a new camera shows a high-definition view of how food travels through our bodies and into our stomachs. Food enters the stomach through a hole at the top. The stomach is a bag of muscle that churns, squashes, and squeezes food into liquid. At the same time, acids break the food down. The stomach walls protect themselves with a lining of mucus. Without it, the acids could digest parts of the stomach itself, causing stomach ulcers. About an hour later, the stomach squeezes the broken down food out through a tiny hole called the Pyloric Sphincter. The food enters the small intestine, an 11-foot coil of tube where we absorb most of the nutrients. The interior wall of the small intestine is lined with millions of microscopic projections called villi. These increase the surface area of the gut, making it easier to absorb nutrients. First, the pancreas pumps out a juice that neutralizes stomach acid. Then bile from the liver breaks down the fats into tiny droplets. Smaller droplets are easier for the intestine to absorb. After an hour and a half, the small intestine has absorbed most of the nutrients from the food. It's time for what remains to move on. It enters the large intestine through this, the Ileocecal Sphincter, a valve that keeps our food from going back where it came from. What's left is a mix of waste food and dead cells from the walls of the gut. The large intestine's main job is to extract water from it. Lots of bacteria live here too, but it isn't because of an infection. We actually need them. They produce enzymes that break down complex carbohydrates in our food, carbohydrates we couldn't otherwise digest. Finally, after about 12 hours, we expel what's left of our first meal.
Okay, so looking at what is starting to happen in all the organs of the digestive system, we start with the mouth, which is where saliva is stimulated by the sight and smell of food from the salivary glands. And we have two processes that are occurring in the mouth. We have the tongue that helps to move food around the mouth to allow it access to the teeth so it can be shredded into smaller pieces, which is called mastication. And also we use our tongue to move our food to the back of the mouth before swallowing down the esophagus. So the salivary glands actually secrete enzymes, amylase and lipase, that break down starch, which is the first point of chemical digestion that occurs in the digestive system. We do have mechanical digestion, which is the mastication of the shredding of food into smaller physical pieces. So there's the salivary glands that's excreting the amylase. So we then move on to the esophagus, and that is a tube that leads from the mouth to the stomach. And there is no breakdown of food in the esophagus. It is just the movement of that food from the mouth down into the stomach. So we can see that we've got movement of the esophagus as it moves the piece of food from the top of the esophagus down towards the stomach. And that term or that movement is called peristalsis, which is the movement of a muscle that moves that food physically down. And it is a series of involuntary contractions that move in a wave-like manner. So what happens is the food reaches the end of the esophagus where we have a sphincter, which is just a fancy name for a muscle, and that esophageal sphincter allows regulated movement of food from the esophagus into the stomach and also prevents any splashback of any of the stomach acid from the stomach into the esophagus, which would actually cause burning of the esophagus. So what you'll actually find is if anyone, you will notice that when you go to throw up, you will have saliva secreted in your mouth, and that saliva actually is there to help protect you from being burnt with from stomach acid, because stomach acid has a pH of about 0.8, so it's very acidic, and this saliva will actually help to protect you. So we've now moved on to the stomach, and this is an organ that holds the contents of whatever it is that you're consuming through your mouth and is the organ between the esophagus and the small intestine. An empty stomach will have the volume of 1/5 of a cup, but can expand to more than 8 cups after you've eaten a large meal. So the stomach is there to help partially digest and physically break down food into smaller physical pieces, but also smaller components chemically. So we have churning in the stomach, which actually physically breaks down the food And again, it is a wave-like motion, so it is the physical breakdown of particles into, or the food into smaller particles. And we also have the digestion, the chemical digestion of food as well. So there's that physical digestion. So we have gastric acids, which is just hydrochloric acid, as well as some enzymes that start to chemically break down the food into what we call a watery paste, which is called chyme. So pepsin is an enzyme in the stomach that will break down protein into its building blocks. So the reason why we have hydrochloric acid in our stomach is it kills any bacteria that might be consumed through the food, and it is actually part of our response to any foreign bodies. So hydrochloric acid does have a pH of about 0.8, so it is incredibly uh, acidic, and we do actually have mechanisms that help to protect our stomach from being broken down by the hydrochloric acid. So the stomach will release food into the small intestine in a very controlled manner, again through another sphincter, and that's called the pyloric sphincter, and it releases it into the first part of the small intestine, which is the duodenum. So the small intestine can actually be broken up into three parts: the duodenum, jejunum, and ileum, and is roughly about 7 meters in length. And this is where most of the digestion and absorption of all of the nutrients that you consume for your food occurs. So when the food does enter the small intestine, the majority of those fats, carbohydrates, and proteins have been physically broken down into smaller molecules, and this helps the absorption of those nutrients as well as the breakdown, the final chemical breakdown of those nutrients as well. So the duodenum is the first part of the small intestine. It's where food is digested here in small amounts, and it's the widest part of the small intestine. When food enters the duodenum, there are several components of the digestive system that have become activated, which include the gallbladder and the pancreas, and they help to allow complete digestion of the nutrients in the food in the small intestine. So the gallbladder is attached to the duodenum, and it's a small sac, this one here, that it is attached to the liver, and it stores bile that the liver produces. So if we go back to the beginning of that, the liver is here, and that liver is attached to the gallbladder, and bile is used as a process in the digestion of lipids. So bile is stored in the gallbladder and discharged into the duodenum when you start eating. And the purpose of bile is that it actually is a type of physical digestion where it breaks fat molecules into smaller globules. So it actually acts in the same way that a detergent does, and that technical term is called an emulsifier. So bile is not an enzyme, it is a chemical that allows the breakdown of smaller physical pieces of fat into smaller pieces. So it's a physical breakdown. So the pancreas also has a very important role as well in the breakdown of food in the duodenum, and it works in unison with the gallbladder. And what the pancreas does is it produces enzyme-rich pancreatic juices that break down proteins, carbohydrates, and fat, as well as neutralizing any stomach acid that might be left over, because we don't want to be breaking down our small intestine, because that would actually damage our small intestine, which would affect the absorption of nutrients. So the pancreas contains a whole bunch of enzymes: trypsin, amylase, and lipase, and they all have different roles to play. Then we move into the jejunum and ileum, which are the second and third parts of the small intestine. So nutrients are absorbed through the intestinal wall and carried to the liver via the bloodstream. In the liver, you actually need to have filtration of those nutrients that have been absorbed before they can enter enter the bloodstream. The lipids actually enter the blood, are absorbed through the lymph system, through the lacteal, which is in every central villi, and are actually moved through the lymph system before being released into the bloodstream. So each villi will have a whole bunch of microscopic microvilli, which really increase the surface area that allows for effective absorption of nutrients. And they move kind of like, think of this as uh, almost like a rug that's on the inside of your small intestine with like a shag rug. And they move in a bit of a wave-like action to allow the capture of those nutrients and absorption of those nutrients. So moving on to the large intestine, that consists of both the colon and rectum, and there is no digestion here. The main purpose of the large intestine is to remove food residue and waste from the body. It will absorb any excess water back into the bloodstream, and those waste products could be cellulose, digestive juices, any excess water-soluble vitamins, and bacteria, as well as any dead blood cells or any dead cells in general. So the rectum temporarily stores fecal matter and is used then released at its own um, convenience through the anus. So the large intestine, although it doesn't produce any enzymes, the bacteria will actually digest soluble fiber, and that allows for the production of vitamin K and some B group vitamins, which can be absorbed and distributed throughout the body. So constipation is a condition that is usually a result of low fiber diet or a low liquid intake or not enough exercise, and results in dry and hard feces that's either infrequent or hard to pass. Whereas diarrhea is kind of the opposite of that, which is the frequent passing of loose, watery, or unformed feces, and is usually the cause of gastroenteritis or food poisoning and can result in severe dehydration. So there is the Bristol stool chart, which has a scale of the different stools and which is the most ideal type, which is number 4. They've used very descriptive terms here that everyone can relate to make it easy to classify your stool on the chart from 1 to 7. So 7 is diarrhea and type 1 would be constipation. And there's just some summary tables that I'm not going to go through that you should have a look at, and because it does give a very good summary of all the types of physical and chemical digestion that does occur, the summary of where the nutrients are absorbed, the site of macronutrient absorption and the chemicals involved. Hydrochloric acid is there for the physical breakdown and bile as well, whereas pepsin and lipase are the actual chemicals that are involved in that macronutrient digestion. Okay, so quickly moving on to malabsorption diseases. So these are usually the difficulty of being able to absorb nutrients due to intolerances or allergies and will require a modified diet. So celiac disease is also known as a gluten or being gluten intolerant. And what celiac disease actually does is it damages the villi in the small intestine, which means that the surface area, those little finger-like protrusions actually flatten, and the surface area is now severely compromised, which means that the absorption of macro and micronutrients does not occur very efficiently, and people that have celiac disease can very easily become deficient in both macro and micronutrients. The only way that you can really treat celiac disease is to avoid all gluten, which is why it's really important that people that do suffer from celiac disease don't consume any gluten because those effects that I talked about before can last up to 6 months, which is pretty severe. So there is actually a celiac app that you can download that allows sufferers a very easy way of looking up ingredients to see if they have gluten in them if they're a little bit unsure. And there are a whole bunch of foods that they need to avoid, but also foods that they can include. And I won't go through these. You can have a look at these in your own time. And the last intolerance that we're going to have a look at is lactose intolerance, which is the affects people where their ability to break down lactose in milk products is compromised due to insufficient enzyme lactase, which breaks down lactose. So if you actually can break down lactose, you're actually a minority in the world population because 60% of the population is actually affected by lactose intolerance. So a lot of people of Aboriginal, Southeast Asian and Mediterranean origin can't digest lactose, and it's actually an evolutionary advantage if you can. And some of the symptoms include severe pain, gas, bloating and diarrhea. So some of the concerns are that people that have lactose intolerance are not getting the recommended daily intake for calcium, phosphorus, and vitamin D, which can lead to deficiencies and deficiency-related diseases, as well as a lack of variety in the diet may mean that they are also deficient in other nutrients as well. So it's really important that sufferers that do suffer from lactose intolerance get their calcium and phosphorus from other food sources that aren't dairy. So some butters and cheeses do have low lactose levels and can be tolerated from some sufferers, but it really depends on a case by case because lactose intolerance is a scale. It's not either you are or you aren't, and some people that suffer from lactose intolerance can tolerate dairy more so than others. So dairy doesn't need to be avoided. It just lactose light options need to be consumed. So if we were to look at lactose per 100 grams. So things like ricotta cheese are examples where you could, so soft cheeses are examples that could be substituted for something like, say, evaporated milk or yogurt. So some yogurts, depending on the type of yogurt, they will actually include the amount of lactose in there so you can work it out.